Hi everyone, I hope you're enjoying your time with us today at Google I/O. Welcome to this workshop, where we'll walk through integrating an Android widget with Google Assistant. I'm Jessica Dene Early-Cha, and I'm a Developer Relations Engineer for Google Assistant. With me today is Matthias, who is a Partner Technology Manager. For this workshop, we'll do a quick overview on app actions, an overview of how Android widgets are implemented in this code lab, and what you'll need to do to modify to accommodate the BIIs. Then Matthias will walk you through setting up your app, creating your capability, implementing the changes to the app, and finally testing it out. After that, I'll be sharing with you next steps. Let's jump right in. App Actions is how you can integrate Google Assistant into your Android app. Instead of having the fulfillment of the user's query be the launch of an Android app, the app's widget can be surfaced on the Assistant's UI. For this workshop, we'll be working on a fake exercise app where users can get information on their latest exercises. Let's walk through how App Action works within this situation. Here we have the user, Assistant, and the Android app. So when I say, "Hey Google, ask Test App about my last run," Assistant will process the input and match it to the Get Exercise Observation built-in intent and extracts run from the input for the About Exercise name parameter. The Android app will generate and send the widget to Assistant. Then the widget is then displayed within the Assistant UI. Assistant can also provide a spoken response to go along with the widget if one is provided. Android widgets are miniature application views that can be embedded in other applications, like on the home screen, and they receive updates. The widget that will be modifying displays the last exercise. The app that will be updating currently implements the widget creation like this. A stat widget object is created, and it queries the database for the last exercise. If there's data, that data needs to be formatted. If it doesn't have data, we'll be using the default empty strings. After that, the widget manager updates the widget. Since we're implementing app actions into the widget flow, we'll need to factor a few considerations. The Get Exercise Observation BII supports parameters and requires a fallback intent. We'll go into depth onto these two items later in the workshop. For now, the parameter considerations can be interpreted as the user requesting a specific type of exercise, like "show me my last run," where run will be pulled from the user's query and set to the parameter. The fallback intent is the situation where a user doesn't specify a type of exercise, so the parameter value is null. In both cases, if a widget is triggered with a BII, you could provide a text-to-speech string for Assistant to announce when displaying your widget. Let's walk through how we'll manage these considerations. Here is an updated view of the flow that takes into the considerations of supporting parameters, the fallback intent, and TTS. To support the parameter, the widget creation flow will need to include querying the database for the last exercise type versus the default querying the last exercise. This will be managed by finding out if the widget has a BII and if it has a parameter. The query will return a live data object. The next step is same as the original, checking if the live data object has data. If it does, the data will be formatted, and if it doesn't, we'll use the default empty data strings. Next, as part of the formatting of the data, we'll need to check if it was triggered by a BII, regardless if it has a parameter or if it was a fallback intent option. That way, the text-to-speech content can be created. Finally, the widget is updated with the appropriate information. With this overview of how the app will be needed to be modified, let's go over with Matthias to download the starter code and implement these changes. Over to you, Matthias.
Hello everyone, I'm Matthias, and as Jessica mentioned, I will walk you through the code lab for integrating Android widgets with the Google Assistant. By the way, you can follow along with our code lab by going to the link on our screen. The code presented here is based on another code lab titled Extend an Android App to Google Assistant with App Actions. If you haven't done that, I would recommend going to that one first. Let's get started by downloading the base files from our GitHub repository as shown on the screen. I've already downloaded the code and opened my Android Studio. I've also added my unique application ID to my build.gradle file and the shortcuts.xml. If you don't have one, check out the CodeLab for instructions on how to get it. Make sure that you're using your own unique application ID and don't use the one you see here. I've also installed the Google Assistant plugin so we can test our app actions using the App Actions test tool. With the base code loaded into our project, we will first get an idea of what this code already can do. For that, we select the deployment target in the devices dropdown and hit the Run button. In my case, I'm using a physical device projected on my computer screen. The device is connected to my USB port, but you can also use a virtual one that you've created using the device manager in Android Studio. You see here the landing screen of our fitness app showing the last activities recorded by the app. Let's now take a look at the existing widget that we will reuse in our CodeLab. For that, we head over to the Fit Actions app on the launcher screen and long press it. Now we tap on Widgets, and the registered widget that has been built for displaying the last recorded fitness activity is shown. We can now drag this widget and add this to our home screen. However, we don't want to do this right now. This was just to show that we have already this existing widget that we can now bring to life inside the Google Assistant. The next thing we're going to do is to test the existing app actions that are already implemented in the base code, namely for start exercise and stop exercise. For that, we first need to make sure that we have our Google Assistant plugin visible. If that's not the case, we can go to Tools, Google Assistant, App Actions Test Tool to make it appear. Make sure that you're logged in with the same account in both Android Studio and your physical or virtual device, which you're testing with. We can now create our App Actions preview by clicking on the Create Preview button. We can leave the app name as the default test app action. We have now successfully created the preview, and we see in the intent dropdown that we can trigger the start exercise and the stop exercise intent. This corresponds to the capabilities that we have defined in shortcuts.xml. We will now trigger the start exercise intent on the device with the exercise name running by clicking on the Run App Actions button. We see that the running exercise is started. We let it run for a bit and can stop it by tapping the X, or alternatively, we could have also invoked the stop exercise intent in our App Actions test tool. Now that we've verified that our app actions are working, let's dive into the actual content of our CodeLab. As Jessica mentioned earlier, we will use the built-in intent get exercise observation to showcase our widget integration. As a first step, we will add a capability element for that BAI in shortcuts.xml. As a side remark, during the CodeLab walkthrough, you will see code appear in my Android Studio window seemingly out of nowhere. This is because I wrote myself a little helper script that pulls in the code for each step automatically and to avoid copy-pasting code with the mouse. So let's add the get exercise observation capability here. What it does, it maps the get exercise observation BAI to the Android intent, marked by the app widget element. So when the get exercise observation is triggered, the Android intent will trigger. But before that, the supported parameters are pulled from the user's input. The get exercise observation BAI supports several parameters, but for this CodeLab, we only need the exercise name, given as exercise observation.aboutexercise.name, as you can see in the parameter section of the intent. Please also note the extra tag of the intent We will refer to this later in the application code. There are 3 exercise types that this application will support: running, walking, and cycling. These exercise types are needed to open the app and start recording that exercise. In order for the assistant to know what this application supports, we need to use inline inventory to provide this information. The way this is done is by adding a shortcut element for each of the supported values and bind each of them to the exercise name parameter of our getExerciseObservation capability. Let's have a closer look how this is done. For each of the supported values for the parameter, we define a shortcut XML element, like this one for running. Through the capability binding and the parameter binding elements, we tell the assistant that this is an inline inventory entry for the exercise.aboutExercise.name parameter in our getExerciseObservation capability. The string array running synonyms contains possible variations of running, like jog, sprint, which are used to let the assistant know to also recognize those phrases in this context. We do the same for the other supported values, walking and cycling, so that we end up with those 3 shortcut elements that you see on your screen. So we are nearly done with setting up our capability. There's only one small thing left to do. What if a user asks for an activity that is not supported by our fitness app, like climbing or any other value? In order to catch those cases, we add a fallback intent to our capability, which is basically an intent that doesn't assume any specific value for the supported parameters. This intent will trigger if the user asks for an exercise observation other than the supported values running, walking, cycling. Please note that it's important that the fallback intent is listed after the app widget tag, because it's the catch-all for the BII. All right, now that the getExerciseObservation capability is established, we need to configure the Android app to handle the request. So first, we are going to add the widgets extension library to our build.gradle file. The AppActions widgets extension library enhances your widgets for voice-forward assistance experiences. This Maven library allows you to provide a custom text-to-speech or TTS introduction for each widget. We therefore add the corresponding dependency into our build.gradle file in the app folder, as you can see here. Because we made a change to one of our build files, we have to click on Sync Now in order to get everything working properly in the IDE. Next, we head over to our Android manifest file in order to add a service for processing the widget request. A service is an application component that can perform long-running operations in the background. It does not provide a user interface. When widget fulfillment is triggered, Assistant sends a request to the app by way of this service. The service receives the request along with the BII, then uses that data to generate a remote views object that knows how to serialize the widget structure. Assistant uses the remote views object to render the widget within the Assistant app. Now that the app is configured, we'll go through and update the code that updates the widget along the lines how Jessica has explained earlier. We will update the code to manage the different flows for BIIs and fallback intents. The source code modifications in this code lab are done in the StatWidgets class. Let's head over there. We'll start by importing the AppActions widgets extension, which will allow us to access the BII and parameters data from the Android intent. It's grayed out for now, which will change once we add code that will make use of it. Next, we'll add a couple of private variables to start our StatsWidgets class. These are needed to determine the creation flow. In order to get rid of the red lines, we also need to add some initialization code for those variables. Let's do that now. Let's walk through the code that initializes these variables when the getExercise BAI is being triggered. The example values that you see in the comments below each of the initialization lines assume that the user has asked about the running activity. So first, we initialize the options bundle. Bundles are objects that are intended to be used across process boundaries between activities with intents and to store transient state across configuration changes. The name of the BAI is available from the bundle using the AppActions widgets extension. So the value of the BAI variable here is the string actions.intent.getExerciseObservation. Next, we initialize the hasBAI flag, which is true in our case. The params variable is set to the bundle object containing information about the parameters of the BAI. In this case, the name-value pair of the exercise name with the value running. The isFallbackIntent flag is set inside this conditional. In our case, because the user has asked about the supported activity type running, isFallbackIntent is false. And finally, the exercise type variable gets initialized with the corresponding enum element for running. Note, for non-BAI triggered widgets, these variables would be null, false, empty, or unknown. Now that we have access to the information that is provided via the Android intent when the BAI is triggered, we will introduce the modifications to the widget creation flow, starting with checking if the widget was triggered by a BAI and that it's not a fallback intent. We therefore modify the updateAppWidget method, which gets triggered whenever the app needs to update the widget. The existing code here only covers the UI part of the widget. Let's add to it to handle the cases when a request comes in from the assistant. The code checks if the widget was triggered by an BAI and makes sure it's not a fallback. If the widget was triggered with a fallback intent or not via BAI, the regular or default widget creation flow will happen. As you can see, we are referring to a new method, observe and update requested exercise, that we now need to define. It will be very similar to the already existing observe and update last exercise function, with the key difference being that the database query will use exercise type value instead of query for the last exercise. The code in this function queries the database and checks if there is data in the live data object, similar to the regular widget flow in observe and update last exercise. The data will be processed like the regular widget flow. Let's get to the fun part, adding some text-to-speech or TTS to your widget. You can provide a TTS string for Assistant to announce when displaying your widget. It is recommended to include this to provide voice support for the users. A good spot for this sample to include would be during the formatting of the data. We therefore head over to our format data and set widget method to add a couple of lines to it. In our strings.xml, there are two strings, one for the speech and the other one for text. The speech string provides information about the logged exercise, such as date, minutes, and distance. You can see the format strings here if I hover over the resource reference. The text string only contains the date of the logged exercise. This is because the widget itself will display the rest of the data and is not needed visually. As you can see, we still need to define the setTTS method, which will actually update the widget with the TTS strings that we've just defined. The setTTS function constructs the data structure needed for the App Actions widget extension and calls its update widget method, which triggers the speech and display output of the widget. We're nearly done now. There's only one thing left to do, namely providing TTS output in case the fallback intent is triggered, which is the case if there's no data available for the given exercise type. Following the same pattern as before, we add a conditional into the respective function, in this case, setNoActivityData widget, and update speech and display text accordingly. Now we're actually done with our code modification, and it's time to get our code to work. We therefore click again on the Run App button to build the app and run it on our device. We can see that the app is working. As expected, the landing screen hasn't changed. We will see the impact of our code modification once we trigger App Actions. In order to do this, we first need to update the App Actions preview, which is done by clicking on the Update button in the Google Assistant plugin. In the first step, where the tool asks us to select and configure a BAI, we select our newly implemented Get Exercise Observation. In the Exercise Observation box, we update the default climbing with the value running. Now, we click Run App Actions.
Test App Action says, your last running activity was on Sunday, April 3rd, and it was for 0 minutes and 0.17 kilometers.
As expected, the widget announces our last recorded running activity. We have now verified that our TTS output is working as expected. Let's do one more test to see that our application logic is working. We will now use an unsupported exercise type, like climbing.
Test App Action says, couldn't find the last activity for climbing.
As expected, the widget announces that no such activity is found. This concludes the Code Lab. Back to Jessica.
Thanks, Matthias, and congratulations on integrating your first Android widget with Google Assistant. We would love your feedback on this Code Lab, so let us know what you think by going to goo.gle/widget-codelab-feedback. Check out our other Assistant sessions, like how Google Assistant architecture powers voice features in your apps, which goes into the Assistant's architecture. Learn about capabilities available to app developers at Google Assistant functionality across Android devices. And finally, Car Talk, Assistant and Android for cars, which goes into how Assistant supports Android app content on Android Auto. On behalf of Matthias and myself, thank you for joining us today, and we're excited to see what you build next. Thank you.